Hello and welcome back to another IB Math speedrun with me, Vince. So in this speedrun we're going to be going over differential equations in exact form and how to use the integrating factor to convert from standard form to exact form. So let's jump right in. So what is a differential equation in exact form? Well, that's a differential equation that we can express as d over dx is times y of x times some function u of x is equal to another function v of x. So, y of x is just an expression in terms of y, and then u of x, and then v of x. So, what we need to, this is very complicated, and it's best to explain it with examples, but we also need to go over what standard form is first. So standard form is when a differential equation is expressed in the form dy over dx plus p of x times y equals q of x. And so in order to convert from this form, where we have to add the term with y, to this form, where we multiply the term to y, we have to multiply both sides by the integrating factor. And the integrating factor is equal to e times the limit the integral of p of x dx. And so this will allow us to convert from dy over dx to d over dx. And so let's go through some questions to show how we do that. So I'll do the odd one. So the first question is dy over dx, or y prime, plus y is equal to e to the x. And so there's no way we could do this with any conventional method. We need to use this new method of converting to the exact form. So we know that this p of x is equal to just 1, since this term here is equal to p of x times y, and this is q of x. So we need to multiply by the integrating factor, which is equal to e to the integral of p to the x dx. So e to the 1 dx, which is equal to e to the x. And we can ignore the constant of integration in that for now. So if we multiply both sides by e to the x, then we have e to the x times dy over dx plus e to the x times y is equal to e to the 2x. And so what's interesting to note here is that this is the results if we product rule the original function d over dx times e to the x times y. So it took me a while to get this, but yes, if you product rule this and you get the derivative with respect to x, you end up with this here. So that's what allows us to convert from standard form to exact form, and this is equal to e to the 2x. Since this is only d over dx, we simply need to get the integral of the other side with respect to x, which is equal to 1/2 e to the 2x. 1/2 e to the 2x plus c. And so finally we have y is equal to 1/2 e to the x plus c times e to the minus x, since we're dividing. So this is our answer. Okay, on to the next question, and the next question is we have x times y prime plus y is equal to x squared plus 1. And so we need to integrate this. So we have dy over dx plus y over x is equal to x squared plus 1 over x. So we have our integrating factor is equal to e to the integral of, actually here we have x to the minus 1 dx. So this is equal to e to the ln x, which is simply equal to x. So the integrating factor is we need to multiply it by x. So if we multiply everything by x, we get x dy over dx plus y is equal to x squared plus 1. And I think I just repeated myself there, since we could technically integrate this right away, but it's good to check. And so we know that this is the result of the product rule of d over dx of x and y. is equal to x squared plus 1. So we have x times y is equal to 1/3 x cubed plus x. So we have y plus c. So we have y is equal to 1/3 x squared plus 1 plus c times x to the minus 1. So this should be our answer. Okay, yeah. And then next question we have dy over dx plus xy is equal to x times e to the x squared. So to get the integrating factor here, this will be equal to e times the integral of x dx, which is e to the power of 1/2 x squared. So if we integrate here, we have e to the power of 1/2 x squared dx, dy over dx plus xy is equal to e to the 1/2 x squared times 1 plus e to the 1/2 x squared. Yep. So then here we can get this is equal to d over dx. Actually, we should keep this as separate term. Oh wait, we're multiplying it. Oh, what am I doing? Oopsies, this is just equal to x times e to the 3/2. I think it is 3/2 x squared. So if we get d over dx, this is equal to e to the we have to multiply this too. So x times e to the 1/2 xy. So we get this is equal to e to the 1/2 x squared y is equal to x e to the 3/2 x squared. So if we integrate the other side, get e to the 1/2 x squared y is equal to excuse me, 2/3 e to the 3/2 x squared plus c. So we have y is equal to 2/3 e to the x squared plus c e to the negative 1/2 x squared. Because the book made an error. The book might have made an error. Oh, that's weird. Okay, anyways. On to the final one, and the final one is x times y prime plus 2y is equal to cosine x. So what we have here is dy over dx plus 2y over x. Or actually, I mean, here we can already just integrate. If we have the term solely as x, we can probably integrate already. Is equal to cosine x. So if we, the only problem is this 2 in front. Yeah, and I think we actually have to divide by x first. So ignore that. 2y over x equals cosine x over x. So we have the integrating factor is e to the 2x to the minus 1. The integral of this at least. So this should be equal to e to the 2 ln x, which is equal to ln x squared. So this is x squared. So we have to multiply everything by x squared. So this is actually x squared dy over dx plus 2xy, which is probably why we have to multiply by x squared, is equal to x cosine x. So we get the integral of, sorry, not the integral, this is d over dx of x squared y is equal to x cosine x. So we have x squared y is equal to, and we need to integrate x cosine x, which is u is equal to x, u prime is equal to 1, v prime is equal to cosine x, v is equal to sine x. So we have that is equal to x sine x plus cosine x, since it's minus minus, yeah. So we have x squared y is equal to x sine x plus cosine x. So we have y is equal to all of that over x squared. So yeah, that should be the answer. Plus c. Oh wait, it is, yeah. It is x squared cosine x, not x cosine. Sorry about that. Yeah, we actually have to integrate to x squared cosine x, which is a bit longer. So we have x squared cosine x. Of course, this is going to be a integration by parts twice, is equal to 2x. V prime is equal to cosine x. V is equal to sine x. So this is equal to x squared sine x minus the integral of 2x sine x. So u is equal to 2x, u prime is equal to 2, v prime is equal to sine x, and v is equal to negative cosine x. So we have, this is minus plus 2x cosine x, and then minus the integral, plus the integral of 2 cosine x, negative 2 cosine x, which of course the integral is simply minus 2 sine x. So this is all going to be equal to something a bit longer that we had here. This is actually x squared sine x plus 2x cosine x minus 2 sine x plus c all over x squared. So yeah, that was that, and then on to the final question. And we're on to the final question, which is x y prime minus 3 over x is equal to 2y. And so we need to solve this question. First I'll divide everything by x, so we get y prime, or dy over dx, minus 2y over x is equal to 3x to the minus 2. So we get that the integrating factor is equal to e to the integral of negative 2x to the minus 1 dx, which is equal to e to the ln e to the negative ln 2 negative 2 ln x. So this is negative ln x squared. So e is equal, so this is equal to negative x squared. No. This is equal to x to the negative 2. So we need to multiply everything by x to the negative 2 again. Okay. So we have x to the negative 2 dy over dx minus 2y x to the negative 3 is equal to 3x to the negative 4. So, of course, this is product ruled, so d over dx times, this is y times x to the negative 2 is equal to the integral, so this is equal to 3x to the minus 4 So we have y times x to the minus 2 is equal to the integral of this, which is negative x to the negative 3. So y is equal, plus c. So y is equal to negative x to the negative 1 plus c, plus cx squared. Yep. And so we have the initial values that, oh, I didn't write them, but we have the initial values that y of 2 is equal to 5. So we have 5 is equal to negative 1/2 plus c times 2 squared. 11 over 2 divided by 2 times 4 is equal to c, so c is equal to 11 over 8. So we have y is equal to negative x minus 1 plus 11 over 8x squared. So that was the final challenge for today. I hope you enjoyed the speedrun, and I hope you learned about exact and standard forms of differential equations. See you in the next one.